5 and 6 sat on the inflection point? Did you guys notice that? If you look at that second derivative of tangent, well, at 0, it's 2 secant, but then that thing right there is going to equal 0. So the whole thing equals 0. So that's actually, if you check to the left and to the right, it's an inflection point, which is true because the tangents, again, are a bunch of these things, and they happen at 0 and pi, and right there, you better believe it, we have an inflection point. So that was kind of neat. So I just checked a little bit to the right. Does that make sense? Like I put a bunch of jumbled mess inside each box, but can you guys see all the information? Do you guys understand why I got the second derivative? Why did I do that? No, busted. On camera. On camera busted.
Sorry.
Why do you get, yeah, exactly. Why did I take the second derivative?
No, it's over or under approximation.
Yeah, to figure out if it's an under or over approximation. Again, if something's concave up, the tangent line is an under approximation. If something is concave down, the tangent line is going to be over approximation. And don't forget, they do share the point. The graph and the line share the point at that point of tangency. Don't forget, there is that one point that they're together. Okay? And also, don't forget, if you draw a tangent line, you guys, if you draw some tangent line, it can go through the graph more than one time. It's just tangent to the graph at that point. That's what I'm looking for. Some people we think about the circle tangent line where the definition is that it intersects at exactly one point. Do you remember that old school tangent to a circle example? You guys know what I'm talking about? So if you're talking about a tangent to a curve, I don't know what the curve happens, but this whole idea of being tangent just means, we're shooting off. It's the approximation of the slope at that point. But everywhere else, it can intersect it at other points. Okay? And then secant line is the average rate of change on some interval. So in order to get a secant line, you need a closed interval. You need two endpoints. You find the two y values, you find your change in y over change in x, and then you have one of the points to figure out the slope of the equation of the secant line. Cool? Any questions on that? Great. Now, did we do both of the free response questions from yesterday? We didn't do the second one? 2002, number 3? You guys want to check it out real quick? Is that a yes? Okay, so again, we can only do A and B in this problem, so... Alright, so you're given some velocity equation, function. And the first question asks, what is the acceleration at time equals 4? How do you figure that out? Yeah, derivative of velocity is acceleration. Okay? And you plug it in and you get negative pi over 6, which you could do on your without a calculator, but this was a calculator question. And that's why there's the negative 0.523 or negative 0.524. And the thing on the test, again, you guys, when you round, what is, will someone do, we should all have our calculators up by now, pi over 6 on the calculator, what is that exact decimal?
5235987.
Okay. On the test, don't forget, 3 decimal places. You either truncate, meaning just cut it off, or round. So this would actually have the 2 answers. If I truncate, it's negative 0.523. If I round from the 4th up, it'd be negative 0.524. And that's why there's 2 answers, or the exact, for this problem. Okay? Don't forget, it's either 3 decimals, either you truncate, meaning cut off, or you round it up. Alright, so now, how do we figure out the statement 1 and statement 2, which ones are correct? The velocity of the object is decreasing, and the speed of the object is increasing. Talk in your groups for a second about that statement 1 to start out. How do I know when, just in general, if I'm given a velocity graph, when the velocity of the object is decreasing? Ralphie, what's the group thinking over there? You guys talking about it? You're not? Oh, that's weird. Yeah, but why? Yeah, you know what I'm saying? Like, going to in calculus terms, Roxanne, if you're asking when something is decreasing, well, when some function is decreasing, well, that's when it's going down. You know what I'm saying? Well, in calculus terms, it's when its derivative is negative. Well, what's the derivative of velocity? Acceleration. So when is the acceleration negative? Would be a way to answer that in calculus terms, Brandon. Does that make sense? Now, read statement 2. So that's a correct statement. The velocity of the object is decreasing, right? Yes. Okay, statement 2. The speed of the object is increasing. And you would have use of your calculator on this question, so you could check on that interval if it's positive or negative. Okay? Now on that same interval is the speed of the object is increasing. Talk about that one. What do you guys think?
Because isn't the like isn't saying that
no, they don't be correct because if that interval of velocity is getting closer to the x-axis, which means it's decreasing, the speed is increasing because the velocity.
Any thoughts, Eve? But you guys, first thought out of the gate. Listen up. What do you got?
Wait, wouldn't it always be positive since it's an absolute value?
Well, what is that? I don't understand what that means. You know what I'm saying?
It's increasing.
well, I said it was true because the velocity and acceleration are the same. So, I mean, would that be for this?
That is a correct calculus way to say it. Something's speed is increasing if the velocity and acceleration are the same sign. Or, another way to say it is what? Another way to say it is if you're going away from the x-axis. On the velocity graph, thank you. On the velocity graph, if you're going away from the x-axis. So it's not always, you know what I'm saying? Because if you're going towards the x-axis, your speed's going 5, 4, 3, 2, 1. Or negative 5, negative 4, negative 3. If that's what's happening, your speed is actually decreasing. Your speed is increasing when the velocity and acceleration have the same sign. Meaning positive velocity, positive acceleration. You guys, a good thing to remember about that is the falling object. You throw something in the air. Like this. You guys checking this out? Is everyone looking? Be careful, guys. There it goes. On the way up, what's happening? Did you get that, Mr. Ken? That was awesome. Why is the speed decreasing? What's velocity? I shot it up. I got a positive velocity. Acceleration on Earth is down. It's negative. So it's slowing down until you get to one point. And then as you fall back down, you start having a negative velocity as well as that negative acceleration, and it starts speeding up. Do you see that, you guys? So a good example to figure out when is something speeding up, all this stuff, always like think about the thing thrown in the air. You know, it's sort of a way to figure all that out. Cool? All right. Let's jump into the next section a little bit, related rates. You guys ready? I said, are you guys ready? All right. Now that's the excitement I've been waiting for. Here we go. Lights on in 3, 2, 1. So 4.6, we're going to talk about it. We're going to talk about it again tomorrow too.